Welcome back to Smith Coding and Design. This is the second tutorial where we are making our DDC pump top on our Tormach 4th axis. And so last time we finished with a 2D adaptive clearing where we went in and cleared out the material for this pocket here in the center. So what we want to do now is go ahead and finish that pocket. So I'm going to go to 2D contour. I'm going to go to my tool library, and again I'm going to select the Gorilla Silverback 3/8 3 flute. So far we've been using the same tool for all of the toolpaths. I'm going to go 8,000 RPM and 30 inches per minute, and that's fine. Now I'm going to go into the geometry tab, and I'm going to select the contour around the bottom of the pocket. Then we'll go into our heights tab. Again, I do not want stock top since we've already faced the top of our part. We are left with model top, so that's what I want to select, again because all the material has been removed off the top of our part. We'll then go into the passes tab where things get a little interesting. So first of all, I want to enable roughing passes. And I want to do that because not only do I want to remove the 20 thousandths we left on the sidewalls, I also want to remove the 20 thousandths from the floor. So by using roughing passes, we'll sort of start in the center and then work our way out until we engage into the sidewalls and finish them. Okay, so I'm going to go with 50% the diameter of the tool. So I'm entering that now. And then we are going to need 3 roughing passes. The next thing I'm going to do is change my finishing step over to be 10 thousandths, and I'm going to use a finishing overlap of 50 thousandths. Okay, so that should be everything that we need in terms of the passes tab and in terms of the linking tab. So we'll just go ahead and click OK. That should finish the toolpath. So there we go. Fusion went ahead and generated it for us. As always, we will right click and simulate. I'm just going to use the little timeline here. So you see we drop down and then we start finishing the floor. So we're just removing that 20 thousandths in a nice smooth circular fashion. We then engage into our sidewalls and then we go ahead and finish them. Beautiful. So I like that toolpath, so that's good. So we'll go ahead and get into our next toolpath. So for our next toolpath, we are going to use another boring cycle. So what I'm going to do to save time here is we can just right click on the first bore and we can say duplicate. And then what I'll do is I'll go ahead and move that to the bottom. And then we'll click on it. And we will need to make some adjustments. So again, we're still using tool 8, 25 inches per minute, 8,000 RPM. We need to go in here and adjust our geometry. So we do not want to bore this hole. So we're going to go ahead and get rid of it. We don't need tool orientation. What I want to do is go ahead and bore the center hole here for our second G1/4. So now what I'll do is go ahead and go to the heights tab, and you see how it has stock top, so that will actually cause us to cut a bunch of air. As you see here, we're actually above the face of our part. So what I want to do is actually change this to selection because we've already removed all the material and finished the center hole here. Instead of stock top, I want to go to selection, and I'm just going to select the bottom face inside of the hole, and that will prevent us from cutting all of the air. We'll now go back into passes, and everything there is fine. We'll leave that default, and we'll leave linking default, and we'll press OK. And now again, we'll go back to our home view, and then we'll just right click and simulate. And then we should just drop right down there in the center and go ahead and bore our hole. Again, trying to go nice and slow to relieve as much pressure as I can. This is a giant cantilever, and what I might do next time is try to shrink the length of the stock more. That way, the less stick out, the less deflection you will have in terms of the cantilever. So there we go, exploring that hole, nice and smooth. So we'll just go ahead and orbit here, and then that'll be fine. As soon as we face the bottom of our part, we'll be able to see the hole. Okay. So that's good. I'm happy with that toolpath. We'll go back to our home view, and then we'll head into the next toolpath. All right, so now we're going to do another 2D contour. So again, to save time, we can go to our previous contour, right click, and just say duplicate. And then we'll go ahead and drag it to the bottom. And I'm going to right click and edit. And so again, still using the same tool, tool 8, which is the 3/8 Gorilla Silverback end mill. 8,000 RPM, 30 inches a minute. That gives us right around 1.2 thou per tooth. We need to change the geometry. And so what I want to do now, let's go ahead and look at our geometry here, is I want to come around and finish the outside. So I'm actually going to go to chain, and I'm going to go to open chain. And then I'm just going to go ahead and orbit around and select sort of the outside contours here. So bear with me while I go ahead and do that. All right, there we go. So that's the outside contour of our part. We'll go ahead and go back to the home view here so we can see that better. We'll click OK. And now we will go into our heights tab. Model top is perfect. Selected contour is fine. I actually want to go, I'm going to go 10 thousandths below the bottom just to make sure that we get a nice smooth finish and make sure that we indeed aren't a little bit above the bottom of our part. All right, so there we go. The next thing I want to do is, yes, I do want roughing passes. This time we're going to want 2 roughing passes, and our step over is going to be 30 thousandths. And then again, I'm going to leave the finishing step over at 10 thousandths and leave a 50% finishing overlap. Sorry, 50 thousandths finishing overlap. So that all looks good. Again, here, finishing feed rate 30 inches per minute, finishing step over 10 thousandths, and we have our roughing passes because there's going to be a lot of material out here in front of the part. We don't want to take that all in one pass. All right, we could, if you wanted, we could enable smoothing and feed optimization. So we'll go ahead and do that. Could do that on the previous contour as well if you want. You could go back and enable smoothing and feed optimization. So we'll click OK. And now we'll go ahead and simulate. And again, I'm just going to walk through the timeline here. So there's our roughing pass. So we kind of engage that corner there. It should be okay, but we want to always pay attention to that and make sure that there's not too much sticking out of that corner where we'd bog down our spindle. I think it's going to be okay. So there we go. We finished the front and the sides. So I think what we're going to want to do next is go ahead and do some contours on the back side here just to provide enough relief for us to come in and chamfer. So we're going to go ahead and exit the simulation. So that's it for the 2D contour in terms of finishing our part. So the more I think about it, the less I like having the stick out here at the bottom. So we're going to go back into our part. Or sorry, back into our toolpath, and let's see what happens if we go below 50 thousandths. Let's see if that will get rid of it. There we go. Okay, so there we go. So now we went ahead and we finished the outside contour of our part and made sure we didn't have any ugly, stick out here in terms of the top hat. Even though it's on the 4th axis, so we really don't have obtube per se, I still prefer to go ahead and get rid of that. So we're going to go all the way down and take all the stock off the sides there. I think that's just a little smoother. All right, so that's it. So now we'll get into our next toolpath. Okay, so for the last toolpath in this tutorial, what we're going to do is come over here to the back of our part and make a 100,000ths relief so that we can go ahead and chamfer around the upper contour on the top of our part when it's time to do our chamfering toolpaths. So to do that, again, we're going to speed up the process by simply right-clicking on our previous 2D contour and going to duplicate. You can also Control D. Then we're going to right-click and edit. And again, the speeds and feeds are the same, 8,000 RPM, 30 inches a minute. However, the geometry is going to change. So we're going to click off our current geometry. Again, I'm going to go to chain and open chain, and I'm actually going to select around the upper contour of the back side of the part here. So let's go ahead and do that. Please bear with me. Beautiful. Okay. Perfect. All right. So now what I want to do is go ahead and go back to our home view so we can see. I'll click OK. And then we will go into our heights tab. And what I'm going to do is I'm going to leave our top height as the model top. Our bottom height is the selected contour, but I'm going to go down past our selected contour by 100,000ths. We'll now go into our passes tab, and so everything here looks okay. We have a 10,000ths finishing pass. We can go ahead and get rid of roughing passes, but what we want to do is multiple depths. And I want to go 50,000ths at a time. All right, so that all looks good. So let's go ahead and generate the toolpath and see what we have. Okay, and so I actually don't like that, because if we go back here to the beginning, you notice we went 50,000ths down from the top of our material, but if we look closely here, since we only faced off up to this edge, there's still material there which we were engaging in. So we're going to fix that by going back into our contour. So let's right click, go to edit. And because we have that little sliver of stock there, let's go back to our heights tab. Instead of our top height being model top, let's go ahead and make it stock top. We'll click OK. And then this should look better. So let's go ahead and simulate. And now we account for that little bit of stock that's left here on the edge. Another thing I could have done was when we did the facing pass, we could have made the stock offset larger so that we wouldn't have to worry about it. So if you wish, you could go back and edit the facing pass to take care of it. Okay, so that looks nice. Beautiful. So again, all we're doing here is just providing, let's go to the side view here. All we're doing here is just providing some relief so that when we come through with our chamfer tool, our tip won't hit the material. We'll be able to go ahead and get that nice chamfer. All right, so that's it for this tutorial. I hope you enjoyed. Please like and subscribe. And now we'll go ahead and go through all of the toolpaths actually on the machine, so you'll get to see me machining the part. So I hope you enjoy that, and I'll catch you in the next tutorial. Alright, so here we are just doing the 2D contour, 30 inches per minute, 20 thou depth of cut, and 50% the diameter of the tool in terms of our width of cut or step over. And again, we're just cleaning the 20 thousandths off the floor and then the 20 thousandths off the side walls, off the side of the walls. So it should go pretty quickly here. And now we're going to jump right into our boring cycle. Again, same tool, 25 inches per minute. We're doing 2 degrees, and we're just making that hole for our second G14 thread. So we might get into the threading either in the next tutorial or the tutorial after that. So now we're doing our 2D contour where we're just cleaning up the sides and the front of our part. So 30 inches per minute, around 700 thousandths depth of cut and 30 thousandths width of cut. Again, we have, I believe, 2 roughing passes, so we're going to do those roughing passes, and then what we'll do is we will transition into the part off, sorry, not the part off, into the relief cut for the chamfering next. Alright, so here is that relief cut for the chamfering. You'll see the tool lift up and we'll begin. 30 inches per minute, 50 thousandths depth of cut, the full diameter of the tool in terms of width of cut. Again, we don't want to remove too much material here, just enough to fit in our chamfer. So that's it for this tutorial, guys. Again, I hope you enjoyed the video of the machining. Please like and subscribe, and I will catch you in the next tutorial.